Hello, everyone, and welcome to course P16, GMA Issues, Resolutions. And this particular little course is consumables, heat, and how the way the heat is, how we have to apply our little strategies to make sure we keep the heat at minimal in the contact tip. A really hot contact tip will die out much faster than any others. Let's go through these one at a time. First, plasma proximity. The plasma proximity represents that 11,000 degree plasma that's being generated being in a close proximity with a contact tip that's going to melt at about 1800 degrees Fahrenheit. Now, this plasma, if you get in too close, if your contact tip to work distance is too close, the plasma has nowhere to go. So it will actually get pushed back and end up being closer and closer than we want it to be to the contact tip. A hot contact tip wears more, elongates more, fills up with spatter more, conducts conductivity, conducts electricity even less. It's a very poor contact tip, one that's hot. It's the responsibility of the diffuser to get rid of that heat. That's why the diffuser is far underrated in its responsibilities and what it needs to do. So plasma proximity is something you or a person who manually welds or programs robots has something they can control. Contact tip to work distance is far underrated for how it can control our penetration zones, balance of heat between the joint, and of course the longevity of our contact tips and diffusers and so forth. Microarcing is a condition that happens inside the contact tip, inside the orifice, specifically in the gap between the wire and the contact tip in that orifice, which is generally anywhere between 5 and 10 thousandths clearance, depending on the company. This microarcing happens as a result of a poor surface condition on the wire. This poor surface condition puts us in a place where the conductivity is questionable, and as the two surfaces are sliding against each other, as with all this friction, it can cause all kinds of little sparks and arcs and burn marks in the wire. Now, microarcing has a lot to do with the brand of wire you buy, and that's something for another class for another time. Shielding gas flow is detrimental to making sure that your diffuser stays cool. The diffuser is responsible for holding the contact tip, and it has a few other deals, but it's to hold for nozzle and everything else. But the diffuser is responsible for getting the heat out of that contact tip too. That's why it's important you have shielding gas flow. That's one of the other things we're doing to make sure, and making sure the shielding gas flow is not just adequate to do the welding, but adequate to keep everything cooled off. There's a bunch of different tests and so forth you could do. If anybody wanted to get a hold of me, I could give you FLIR examinations if you wanted to, and like procedures, and you could actually check yourself and see, is my contact tip being cooled quickly enough with my current flow rates? Contact installation and torque. If you're and I don't know how many plants I go into and everybody's finger tight. I have no idea who started this or why, but finger tight is not an acceptable way to put in a contact tip. An electrical connection requires torque, force, pressure, and it requires the right materials and the surfaces to be properly clean. If you don't have enough force and pressure in those connections, you are going to have arcing, and your contact tip will arc inside the diffuser. Now this fries the diffuser, of course, because the threads are going to get messed up. But just as important is you're not going to get a good weld out of it. You will get sputtering if there's any type of arcing going on anywhere in your welding circuit, and you get arcing anywhere else. This is going to be your challenge. So if you can walk up to a contact tip and you can grab your fingers and you can take it out after it's been running, it was not put in tight enough, period. Now, some contact tips, let me just put this out there. Some contact tips use a very fine thread. Now, I'm not a fan of these threads because of a fine thread, because I don't believe you can get them as torqued as you really should be able to. I like a large coarse thread, buttress if possible, but nice tough threads, and making sure you properly have a proper amount of torque on it is good. Lastly, electrode selection. The electrodes, all these different wires you can buy, whether you're talking about solid wire, flux cores, metal cores, they all have some level of a post finish on them. That is, they've decided what they want to put on the wires to make sure that the wires stay corrosion free. Even putting them inside the drum, they all, no matter what it is, because these electrode companies use these different post finishes to get them to run a certain way. Every time I see a brand new wire, I want to see how it runs. I commonly get my scope out and see what it's like compared to the other wires, because you don't know what that surface finish is going to be like. You don't know if they're very good at putting a certain post finish on or poor at it. Like I said, they use waxes, oils, but each one of them have a very distinctive signature. That if you're into use the scopes and everything, you can actually know these well enough. You can learn these well enough that you can identify what wire it is by what pulse it's on and whose wire you're using, and you'll be able to get a proper signature to do that. So making sure some wires do run differently. If you change plants, if you worked in one, you're going to another, and you think, well, this is really, really strange. It probably is that case. But there are ways around it. Every company learns the wire that they are using, and they make the adjustments accordingly. And that's it for this presentation. Thank you very much for your time.